So as we're looking at this question, we are given that we have a right triangle, and we know that we have a right triangle because when we look at the box right here that tells us we have a right triangle, we know directly across from it over here, this is the hypotenuse of it, and they're asking us to find length C. Now, this right here is angle C, so I'm going to go ahead and put that in. This is going to go ahead and be angle C. That's what we have to find first. Now, how do I find angle C? Well, we find angle C because I know I have a triangle adds up to equal 180 degrees. So to find angle C, it's just 180 minus 90 minus 29, or you can make that shortcut of just doing 90 minus 29, and I get that the measure of angle C is equal to 61 degrees. So this one inside here, we're going to change that and not leave it as C anymore, and just rewrite that as the fact that I know that this is equal to 61 degrees. Now, the next thing I need to find out, if they're asking me, is they want me to find the length of C. Well, if you remember in the last video, we take C, we go directly across from wherever angle C is, and this will give us the fact that this is side C that we're looking for. So when you're looking at this, what information do we have here? Well, I know that the 5.8, this represents the hypotenuse. So we actually have two ratios that we can set up. So again, we're going to reference that idea that we have that the sine is the opposite over the hypotenuse. The cosine is the ratio of the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. This is commonly referred to as SOHCAHTOA. So there are several different ways we can write this. Let's first look at angle C. All right, so let's just start off with this thing. We're starting with angle C, 61. So the sine of 61 degrees, the sine is equal to the opposite over the hypotenuse. So the opposite of 61 is C that we're looking for, and the hypotenuse is 5.8 centimeters. So I'm going to go ahead and write that down. And that's the value that we'd be looking for. So without the words in there, I can go ahead and say that the sine of 61 degrees is equal to 5.8 over C. Now, could I solve this for C? Absolutely. I put the sine over 1, and I go ahead and using ratios, I'm going to rewrite this. The C comes up, the sine goes down, and C is equal to 5.8 divided by the sine of 61 degrees. You can go ahead and put that sine of 61 in your degrees in your calculator. Next section, we will not be using your calculators at all, and you will find out that is equal to 5.073, because the directions have asked us to round to 3 decimal places. Now, if you're asking yourself, could I have done this a different way? Absolutely. I'm just going to put this up there in the corner so we can go ahead and reference it later. Let's say instead of using the sine, I wanted to use the cosine. So if I go ahead and look at the cosine is of 61 degrees would equal the adjacent over the hypotenuse, right? But if I look at this, and the adjacent side of C would be this side right here. I don't have that side, so I can't really use the cosine of 61 to solve for C in this case. Now, if I wanted to label that, that side would be side B, and I could find that, but we're not asked to do that for this question. But if I wanted to, that would just be the adjacent side, which is side B, over the hypotenuse, which is still 5.8 centimeters. That would be one thing. But I do have another possibility here. I do have this possibility of this other angle, this angle B. So to write the cosine with that piece, I can go ahead and say that the cosine of 29 degrees is equal to the adjacent side. And again, the adjacent side is the side that is touching angle B, but not the hypotenuse. So this would be side C over my hypotenuse, which is still 5.8 centimeters. Now, how do you solve this one? This would just be 5.8, because that cosine is over 1, and bring the 5.8 up, and I'm going to multiply it times there. So it's 5.8 times the cosine of 29 degrees, which is equal to C. Put that in your calculator, and yes, you're going to get exactly the same thing. Still going to go ahead and be 5.073, rounded to the third decimal place. You can use either the sine or cosine to solve for length C. Same thing would be true if I asked you to find side B. The only difference is how you set up the ratios.